Hi guys. Well, we've been talking about relations and functions, and we're going to continue that today. This is section 2.2. We're looking at today slope and slope-intercept form, and we'll just get to slope today. So let's look at that. What is slope? Well, slope is the ratio of the vertical change to the horizontal change between points. Rise over run. Remember, the points are just the ordered pairs in our relation or our function. And so we have a graph here of a straight line, and that could be a function, which of course is a specific kind of relation. Every point represents an ordered pair, and we look at these points here. We have one that's labeled x sub 2 comma y sub 2, another one x sub 1 comma y sub 1. So the ratio of the vertical change to the horizontal change. Well, what does that look like? The vertical change is how far up we're going when we go from one point to the other. We call that the rise. Okay? So the y-axis is the vertical axis, the x-axis is the horizontal axis. Remember, the y values are the second number in the ordered pair. The x values are the first number in the ordered pair. And that's why we have this x sub 2 being the first number, y sub 2 being the second. X sub 1 is the first, y sub 2 is the second. And again, in that vertical direction, counted along the y-axis, how far up do you go to get from one point to the other? That's the rise. And then in that horizontal direction, which means running along the x-axis, how far over do you go? How far over is it from the x location, so to speak, the x coordinate of the first point to the x coordinate of the second point? How far over is that? That's the run. The rise over the run is the slope. So, and in words we could call the change in y is the rise, and the change in x is the run. The change in y being, again, how far up are you? And you can calculate that with this formula. Right here, to find the slope between 2 points, use the following equation. M is our symbol we usually use for slope, equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay? Again, y sub 2 minus y sub 1 being the vertical change, or also called the rise. You can actually calculate it by subtracting those values. That tells you how much does it change as it goes from y1 to y2. Well, subtract. That's how much it changes. Y sub 2 minus y sub 1. And similarly for x. X sub 2 minus x sub 1 tells us how much it changes along that x-axis. How far is the run? Well, just subtract, okay, the x values. That tells you how far it moved in the horizontal direction. So that's the formula. That's how you calculate it. So let's do some examples. We'll leave the formula there. I think we can leave it about like that and see and do all our examples. Okay, so we have these 2 points. We do not have the picture, but that's okay. So we're just going to calculate. And so I'm going to go ahead and label this, okay? This one is our x sub 1, right? And then this is y sub 1. And then our other point is right here. This first one would be x, the first the first value in that ordered pair is x sub 2. And the second value in that ordered pair is y sub 2. Okay, so there's our ordered pairs. So all we do is plug into this formula to find the slope. Here we go. Okay, in the top, y sub 2 minus y sub 1. Well, y sub 2 is 5. Minus y sub 1 is 6. And then on the bottom, x sub 2 minus x sub 1. X sub 2 is 2. Minus x sub 1 is 4. So that should be it. What do we get? On the top, 5 minus 6 is negative 1. On the bottom, 2 minus 4 is negative 2. Comes out to 1/2. Because negatives cancel, and that's our slope. Okay? Okay, so let's look at this one. Now I won't label them this time, but we know this first x value in the first ordered pair is x sub 1, and then the y of that ordered pair is y sub 1. And this first number in the second ordered pair is x sub 2, and the second one is y sub 2. So we apply our formula. Y sub 2 minus y sub 1, so that's 2 minus 4, right? And on the bottom, x sub 2 minus x sub 1, that's negative 1 minus negative 1. Okay, so we're subtracting a negative there. I'll write parentheses around it. Okay, so on the top we have 2 minus 4, that's negative 2. On the bottom, 1 minus a negative 1, that's 1 plus, I'm sorry, it's negative 1 minus a negative 1. So that's negative 1 plus 1. So that is 0. Okay, so what do we do with that? We have this value negative 2 over 0. What does that mean? Can you do that? Well, it's actually undefined, right? 2 over 0 is undefined. So, what is the slope then between these 2 points? What do we say? We say it's undefined, or we say there's no slope. There simply is no slope. Okay, you could say it either way. Now, what is these points? How are they going to look relative to each other? You see, the x values are the same in both cases, negative 1. So there's no run at all. It doesn't go anywhere left to right. It doesn't go anywhere horizontally. It stays at negative 1. But the rise does change, right? That is, the y value changes. So there is a rise, and we found that was negative 2. So this thing doesn't run at all, but it does rise. So that just tells you they're right on top of each other like that. We could draw them. Let's go ahead and plot them real quick. So you have something like this, and negative 1, 4 would be about right there. And then negative 1, 2 would be about right there. So there's our points, and they're just right on top of each other. If we were to draw the line, it's just straight up and down, right? So that's what it looks like when you have the situation of an undefined slope. Okay, but for calculation purposes, it came out like this. Even if we don't draw the picture, we know it's undefined. Okay, so let's look at this one down here. We have 2 points, that is 2 ordered pairs. We take y sub 2 minus y sub 1 for the numerator, and this right there is our y sub 2, and that's our y sub 1, right? So that's 3 minus 3. And then, write that a little bit better. In the denominator, x sub 2, which is this one, minus x sub 1, which is that one, negative 1 minus 7. Okay, so in the top, that gives us 0. The bottom, that gives us, get rid of those underlines. On the bottom, we get 1 minus 7, which is negative 8. So we know what that is. That's not undefined. That's a number. 0 divided by negative 8 is 0. Okay, so that's the slope of 0. And again, don't think that's there's anything wrong with that one. That's simply what it comes out to, is 0. Just want to write it a little bit better. Okay. So, what would that look like? Well, let's go ahead and make a little picture of that one. Scroll up a little bit. Give us more room. Just a little. And make a little graph here. So our first point is 7, 3. Give myself a little more room to draw. Something like that. So there's 7, and up 3 is actually over 7 up 3, about right there. And then our second point is negative 1, 3. So that's here and up here. So those are our 2 points. If we have a line, if we don't really, today we're not looking at the rest of the data, we're just looking at these 2 points. But perhaps they do perhaps the entire relation is on a line. And at the beginning, the picture we looked at, that was the case. But these 2 points, yeah, they were, if we put the line between them, it's horizontal, right? So that's what no slope looks like. I'm sorry, that's what a 0 slope looks like. Very important difference. No slope at all looks like this. We call it undefined slope. Might be a better way to say it so I don't misspeak. That's undefined slope, vertical, and a slope of 0 is horizontal. Okay? So one more example, and this one we are just given the points in plotted on a Cartesian plane. Okay, put the labels on these axes, x-axis, y-axis. That's another way to show them, right? We can show them graphically. We're not given the ordered pairs themselves. So we can do this without writing down the ordered pairs, right? We just want to know the rise over the run. So what is that rise? We can look at the picture. How far up is that? Okay, let's count. Looks like 1. Here we're at this level, right? So that's 1, 2. That's how far up we're going. 1, 2. That's the rise. The run is how far we go over. Okay, that's that. And we go, it's 3, but the sign, of course, is important. Is this positive 3 or negative 3? When we did the calculation, we got a negative number, for example, on A, and we got that from our calculation. When we subtracted 5 minus 6, we got negative 1. In some cases, we got a positive number, or we might get 0. So all of these were either negative or 0, but you could get a positive number. When we are looking at the points on the graph, and we're not looking at the actual ordered pairs, We just have to know which direction is this. Well, that's going in the negative direction, right? So that's -3. Okay, so we get from that diagram that the slope is, write it right here, rise over the run. The rise was 2. The run is -3. And so that's -2/3. Actually, we don't even have to rewrite it. It is -2/3. Okay, so just for fun, let's go ahead and write down what those points are. Okay, this one down here is 1, 2, 3, and up 1. So that's 3, 1. And the other point is 0 on the x-axis, right? You're not going to the right or the left because the number is plotted right on the y-axis. So as far as the x value, it's just 0. I hope that's not too tricky, and you might have to look at that again if it's been a while since you've done these. You know, this would be 1 if we were here. This would be -1. Well, right there for x, that's just 0. And the y is 3. So there's our point in ordered pairs. And so we could use that to and use our formula. I'll bring it back and see if we get the same thing, which we will. Either of these points can be used as x sub 1, y sub 1, and the other one is x sub 2, y sub 2. It doesn't matter which one you use. So what we've been doing is calling the first one the x sub 1, y sub 1, the second one the x sub 2, y sub 2. So let's do that. So we have y2 minus y1, that's 3 minus 1. And we have x sub 2 minus x sub 1, and that's our 0 minus 3. Okay, and what do we get? Well, we get 2, and we get -3 on the bottom. So that's good. We got the same thing that we got up here, but we just went ahead and did it with the numbers that time, just to get a little more practice and familiarity with it and see that they are the same. So that's all for the slope. Next video we're going to look at slope-intercept form. So see you then.